audible? Hello everyone, I am audible.
Yes, ma'am, you are audible.
Can you see my screen? My screen is visible to you?
Yes, ma'am. Yes, ma'am.
Yeah. So in previous class we have discussed up to, I think we have discussed up to, let me check. One second. Okay. We have discussed up to, okay, uh, let's start with let's start with the statistical theory and molecular weight distribution of linear polymer. Okay. So by the statistical theory, it is said that if nx be the number of molecules, nx be the number of molecules of degree of polymerization at conversion p, nx be the number of molecules are of degree of polymerization at a conversion p. See, if we have a polymer system where degree of polymerization is equals to say 100, then nx be the number of molecules with polymerization 100. So we can write it, instead of x we can write it 100, and it will be number of molecule with polymerization, degree of polymerization is equals to 100. This is what it is mean. uh, Dr. C. Shabori Nathan, please mute
Madam,
yourself.
this is the first term, right, today?
Yes, yes, this is the first slide. This is the first slide. I just have started it.
Okay, thank you.
Okay. And n be the total n be the total number of molecules of present at conversion p. So n be the number of molecule which has a conversion factor p, which has a conversion factor p. So we can say nx by n is the fraction of molecule with the degree of polymerization x. Okay. P is the extent of reaction, n0 is the initial number of molecules, and Wx is the weight fraction of the x mass. So nx by n be the number fraction, and small nx by small n be the mole fraction. For the mole, we can just reduce the number fraction equation to the mole fraction. That is, for mole, nx equals to n into 1 minus p into p to the power x minus 1. So the formula will be the same with the number and mole fraction, but instead of number fraction we will use their number of moles. Okay, so now we are going to start some problem with this formulas. Okay, consider a polymerization of the following monomer of nylon 6. This is the polymerization. When the extent of reaction is 99%, the mole percent of monomer present is the mole percent of monomer that present in the system we have to calculate. So let's start. Okay. Okay. So here we have to calculate, I think we have to uh, the weight of percent of the following species on 99% conversion, when the 99% of conversion mole percent of the monomer. So first we have to calculate the weight percent. So for weight percent our formula is this. So for this is the problem, and for weight percent our formula will be the formula associated with Wx. So we have to find out Wx, and our conversion factor P is 99%, that is 0.99. So let's write the formula, that is Wx is equals to x into 1 minus p whole square e to the power x minus 1. So now we have to understand what is the degree of polymerization, what is x. We have to find out the value of x because we know the value of p. If we can find out the value of x, we can easily calculate our Wx. So going back to the problem, here degree of polymerization is not mentioned. So can you tell me how you can confirm what is the degree of polymerization? Clearly here not mentioned any degree of polymerization, but degree of polymerization is given in the system. Can you tell me what is the degree of polymerization of the system? Anyone?
You're asking the formula for the degree of polymerization, ma'am?
I am asking what is the degree of polymerization for this system. Here is given, but by a convention here it is given, not clearly mentioned. I want the answer to that. Just read the problem once and it will you can find it out. Yes, degree of polymerization is 100. Good, because here it is written degree of polymerization is 100. So x will be 100. So our degree of polymerization, that is x is equals to 100. So now we will come with the formula. Wx will be 100 into 1 minus 0.99 to the square into 0.99 to the power 100 minus 1. So let's solve it. Try to solve it and give me the answer. I am giving you 2 minutes.
Ma'am, in formula, in formula Wx equal to x into 1 minus p, close bracket whole power square, p power x minus 1, right?
Yes.
Okay, thank you.
Ma'am, is it 0.0036?
0.0036. Yeah, you are right. It is 0.0036. So tell me what percentage? 3 point, 0.36%,
Yes,
correct?
ma'am. Yes,
Okay.
ma'am.
Now I am writing the value so that everyone can understand. That is 100 into 0.01 square into 0.99 all to the power 99. And Wx equals to this value of this will be 0.369, and it will becomes 3.69 into 10 to the power minus 3. This will become Wx equals to 0.369%. So weight percent present of degree of polymerization 100 at a 99% conversion, it is only 0.369%. Next, again we back to the problem. Here they are asking when the extent of conversion is 99%, the mole percent of the monomer present is, we have to calculate mole percentage of the monomer. Now in the formula, all the formulas are involve the number of polymer molecules, not the monomer molecules. So how can we calculate this? Just here x is denoted the degree of polymerization. If I say the degree of polymerization is 1, then what? Then there is no polymerization there. I am talking about actually the monomer unit if degree of polymerization is 1. So just this formula slight modification where x is equals to 1 for monomer units. We will calculate the mole fraction of monomer. Mole fraction of monomer means n1 by n. What? Here I say that we need monomer conversion percentage. So we consider the degree of polymerization will be 1 and the extent of reaction, that is P, is equals to 0.99. Then I told you the formula with the mole fraction will be same as the number fraction. So the formula reduced to n1 equals to n into 1 minus p into p to the power x minus 1. So it becomes so here n1 by n becomes is p to the power 0 as p to the power 0 is equals to 1. Then this is entire quantity is the mole fraction. This entire quantity is the mole fraction. Then 0.99 is equals to 0.01. And the monomer present in the system in percentage will be 0.01 into 100. That will become 1%. Is it clear to all of you? Can I move to the next sum? Any question?
Experiment one more, ma'am.
Yes. Okay. Tell me.
Can you?
Ma'am, One doubt, ma'am. Ma'am, in the previous slide, you have shown the formula, right, ma'am?
Yes.
In that second formula, it is having that 1 minus p whole power square.
Yes.
Uh, how we can differentiate from the first formula and the second formula, ma'am?
See here nx means the number of molecules with degree of polymerization x, and n0
Yes,
is the initial number of molecules, and n is the number of and n is the total number of molecules. So when the ratio is the x mass with the total number of molecules, then we use this formula. And if the initial number of molecules means the when starting the reaction, that is the presence of monomer molecules, that monomer molecules is signifies as this. And
yes, ma'am.
this is the very initial stage of reaction, and this is for the at any time t for the reaction, where n denotes the number of molecules both in the reactant and product side. Is it clear?
Yes, ma'am. Yes, ma'am. Now it's clear, ma'am. Thank you.
Anyone else? Okay, I am moving to the next problem. Here is the next problem that you have to solve by your own and tell me the answer. This the problem is, consider the polymerization of 11 amine amino decanoic acid. This is this from to form nylon 1,1 at the conversion of 98% of conversion. Calculate the weight percent of the trimer species present and the mole percent of the trimer thesis present. Trimer species present. So I am giving you 3 minutes to solve this problem. If you have any doubt regarding this problem, you can ask me freely.
And what is the X value we have to give it for this, ma'am? The weight percent of the Dremer species.
Yes. What is the this is the catch. Just read the question properly. A and B, what the question is there. Just read the question properly, and then you can find out the X value. If I told you, then the catch is the no meaning of giving the catch. This, see here it is written trimer species. Trimer means x equals to 3.
3. Yes, ma'am. Now I got it, ma'am. Yes, ma'am. I got it. And is it 1.1 into 10 to the power minus 3?
okay. I also have to calculate because I have not calculated it.
Yes.
So this will be your problem of today. First problem, that is 18.1. Okay. So this is the 18.1. This is the extension of 18.1. Now I am going to show first weight percentage, the species is trimer and conversion is 98%. So we have to
Ma'am, can you please show that slide 18, part A, 1?
eight.
Then can you please show next slide, ma'am?
Yes.
Thank you, ma'am. Thank you.
Okay, so we have to calculate weight fraction at trimer species where x equals to 3 and p equals to 0.98. So for weight fraction our formula will be W3 is equals to, forgot the formula, x into 1 minus p square, x into 1 minus p square, 1 minus p square, p to the power x minus 1. So x is 3, 1 minus 0.98 p square into p to the power 3 minus 1, that is, sorry, so it will become is 1.15 into 10 to the power minus 3. This is the weight percentage or weight of the trimer species present, and for the mole percent, that is n3 by n we have to calculate. For this our formula is 1 minus p, 1 minus p into p to the power x minus 1. So it will be 0.98 to the power x minus 1, that is 3 minus 1, and nx by n equals to and it will become 1.92%. Is it okay? The answer that you have calculated, it's fine? Okay. So we have seen the problems regarding these three equations. Now we are moving forward to our kinetics of step growth polymerization. We have two cases here, that is external catalysis at external catalyst added or self catalyzed. Self catalyzed we have solved many problem previous classes. So here is external catalysis added. If the external catalysis is added, then the derived formula is Xn equals to 1 plus C0 Kt, where A and B is the, if A and B has the equimolar stoichiometry, then the formula reduced, we can write this formula also, that is both sides square, nothing else. And If it is a closed system means equilibrium consideration, reversible polymerization, and it is a closed system. Closed system means the external acid catalyst polyesterification reaction where the initial hydroxyl and carboxylic group concentration is C0, and closed system means the byproduct is completely removed from the system, that is the closed system. So then the degree of polymerization xn is equals to 1 plus k to the power half. K is the rate of rate constant of the polymerization, and Pe is the equilibrium conversion. Equilibrium conversion is Pe, and in any condition the concentration of H2O remains in the system, or we have to pick it up, that is that is given by this equation. And for open driven system the degree of polymerization equation will be this. And for non-linear step polymerization means where the functionality is greater than 2, not equal to 2, greater than 2. Let's say one polymer has functionality 3, other has 2. So then the average functionality will be 2.5, and this will lead to the non-linear polymerization, because greater than 2 functionality will leads to the cross-linking or branching of the system. And for the non-linear step polymerization, P critical means the above which gelation will occur, above which the gelation is occur is called the P critical. It is 2 by F average. This is the whole formula for the external catalysis of step growth polymerization. So next problem 19.1. Sorry. For an external acid catalyzed polymerization of an equimolar mixture of a diol and diacid, the time that was needed to reach the 98% conversion is 80 minutes. The time required to increase the conversion from 98% to 99.5% you have to calculate. So we have to calculate the time to complete the reaction from 98% to 99.5%, and for 98% conversion it will require 80 minutes. So let's start. Okay. So for here, see, external acid catalyzed. So we will write Xn, this is our formula. So Xn is also degree of polymerization, and degree of polymerization can be written as 1 by 1 minus P, and this will become so for case 1 P is 98%, 0.98, and time taken to reach is 80 minutes. So now we are putting this value here. So this will becomes 2. Up to this you can you have no doubt, right? Okay. So case 2. Case 2, I don't know what is the T, but P is I think 99 or 99.5%, 99.5%. That is 0.995. So 1 plus K0C is, previously we have calculated K0C is this, and we don't know T. So by calculation it becomes 200 is equals to 1 plus 0.6125 T. Oh, this is case 2, so we have to write it here, T2, T2. Here also we will write T2. So to progress the reaction, so progress the reaction from 0% to 99.
Can you show the previous slide?
Yes, yes.
Okay, thank you.
Okay. So from 0% to 99.5% conversion, the time taken is 324.9 minutes. And from 0% to 98% conversion is given as what? That is 80 minutes. Okay, that is 80 minutes. So the time required from 98% to go to 99.5%. So from 98% to 99.5%, the time required will be 324.9 minus 80 minute, and this will become 244.9. Is it clear for all of you, or you have any doubt, you can ask me.
Ma'am, please show the previous slide, ma'am. How this 200 came up? 1 by 1 minus 0.9.
Clear, or else I'll
Simplification. Okay, ma'am. Yes, ma'am. Now I understood. Please show the previous slide, ma'am. I will take this. Yes, ma'am. Thanks, ma'am.
Okay, so 19.1 we have done. We will proceed for 19.2, and this you You will try this problem. I am giving you 4 minutes to solve this problem. Yes, Vinny Bhagrashi 170. Answer is 170. T2, yes, answer is 170.48. Yes, you are right. So let's solve it. So here for case 1, P1, sorry, and P2 is equals to 0.992. T1 is 60 minutes. So we have to find delta T, that is T2 minus T1. for one by 1 minus T2 will give you 1 plus KC0 T2, then it will be 1 by 1 minus 0.992 gives you 1 plus okay. So the remaining time, that is delta T, will be T2 minus T1. This is equals to 230.48 minus 60, that will gives you 170.48. Okay,
Ma'am, can you please show the previous slide once?
this one, this one. Think,
Can you please show the next slide after that?
yes. And this is the third one.
Yes, ma'am. Thank you, ma'am.
So we have done with this problem. So now coming this, consider a mixture of the following monomers along with their coefficient is glycerol is 2 mole and phthalic anhydride is 3 mole. That is, this molecules present in the, we have taken 2 moles, and this phthalic anhydride we have taken 3 mole. The extent of reaction at which gelation occurs for the above mixture is, and also find the average functionality. So you have to find the average functionality, that is F. F equals to what? F average. And also you have to find the critical extent of reaction above which the gelation will occur. Okay. So here we can see that this is this molecule have a functionality is equals to 3, F1. And for F2, we all know phthalic anhydride present in this form. This is a cyclic form of phthalic anhydride, but phthalic anhydride.
Ma'am, the structure is not visible clearly, ma'am.
Come on.
Yes, ma'am.
What I am highlighting here, that is visible?
Yes, ma'am. That is visible, ma'am.
And this is, that is the structure highlighted.
Yes, ma'am.
Okay. This is phthalic anhydride. is given as this. But phthalic anhydride, when takes part in reaction, it looks like this. So phthalic anhydride has an average functionality is equals to 2. So phthalic anhydride has an average functionality is equals to 2. So if average will be number of moles of taken taken of glycerol, it's 2. Number of moles of glycerol taken is 2 with an average functionality 3, and phthalic anhydride is taken as 3 with an average function with an functionality 2. And the total number of mole will be divided by total number of moles, that is 2 plus 3. So it will give you, if average is now for critical reaction extent after which the gelation occurred, that is PC is equals to 2 by F average, and that is becomes 2 by 2.4, and that will give you 0.833, that is the percent of PC is equals to 83.3%. Okay, now let's next problem. This problem you will solve your own. 21 2. 1 is done. I am giving you 2 minutes to solve this problem.
Can you please go in next slide?
Average functionality is 2.6. And the extent of conversion percentage is 77%.
Let's solve it. If average is 4 into 1.5,
Ma'am, in a second structure, it's not a functionality 4.
no, 1 second. Yes, the functionality is 4, there is 4 OH groups.
No, in a second structure of
Second structure, the functionality is 2.
adipic acid.
COOH is the functional group. It's 2. It's it's okay.
Yeah, it's okay. Okay.
So it becomes 6. Now PC is equals to 25.6 is equals to 769. This is equal 76.9%, which is close to 77%.
I think F average is a 2.8.
Sorry,
Functionality average is a 2.8.
2.8. No, it's coming 2.6. Let me check it once. No, it will be 2.6. You check your calculation.
14 upon 5, right?
14 upon 5. So, no, it is 13 upon 5.
7 plus 7.
Not 7 plus 7,
Okay, 6
13
plus.
plus
Oh,
7.
yes. The 13. 13. Okay, yes, yes. Okay.
Okay. Next, the 22.1 problem. The polymerization between equimolar amounts of diol and diacid. Equimolar amount, here is the catch. Diol and diacid with an equilibrium constant of 100 and initial monomer concentration is 2 mole. The reaction is carried out in closed system without removal of the byproduct. Then the expected degree of polymerization, extent of reaction if the reaction at the extent of reaction if the reaction at the end of the reaction, that is the critical reaction, and the concentration of H2O that must be lower to obtain the degree of polymerization 100. So many things are there. So let's start with 22.1. Yes. Okay. So they are saying equimolar amounts of diol diacid and it is a closed system. So back to the slide. Closed system and closed system and equimollar stoichiometry, that is this. Closed system and equimolar stoichiometry is this. It is also equimolar stoichiometry, but it is external catalysis. It is not a closed system. Okay, so we use this formula, and the end of reaction, that is PE, which is we have to calculate. Okay, so our formula. So our formula, that is Xn is equals to 1 plus k to the power half. So our k is 100. So Xn will be 1 plus 100 to the power half, and this will be 11. And next we have to calculate the end of reaction.
Ma'am, can you please show that question slide once? Yeah, ma'am, done. Thank you.
This will give you P is 0.90 and P is equals to 90%. So this is 22.1, and you will. Acha. Then the level of H2O. We have to also calculate the level of H2O. That is 100 into 2 divided by 100, 200 minus 1 is H2O is equals to
Our action is 11, ma'am.
it is so. No, H2O must be lower to obtain the degree of polymerization 100. Our our
Okay,
expectation
okay.
is 11, but your question is 100. See. Okay. Now solve 22 1 22 2 system.
Can you show the previous slide?
Yes.
Thank you, ma'am.
Please show the calculation of extent of reaction on that calculation set. Yes, ma'am.
Anyone knows where I can get the previous lectures?
So you problem solving class or what exactly?
Problem solving class, ma'am.
Problem solving class actually you can get the link from the in this type in the course where you complete the program. There is the uh, one portal called this from this polymer site. Here you will find that problem solving exercise tutorial 5. Here uh, problem solving database here you are finding the link of this one to access the problem solving class. Okay.
Yes, got it. Thank you. Thank you. Thank you.
For the level of water, this part, what formula we are using? So can you go to the equations slide where all these equations are placed? Yeah. Okay. 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 Thank you.
Anyone want to answer? Degree of polymerization?
Xn is 13.24, ma'am.
And extent?
The extent is 92.93%.
Some 92.9. And the calculation of H2O?
That I'm calculating now.
Yes, 13.24. So I am gonna solve. So 115 is 1.5 molar and it is a closed system. So we have to find the degree of polymerization, that is Xn is equals to 1 plus e to the power half 1 plus t to the power half, and this will become 13.24. Now critical concentration, that is the end of the reaction, can be calculated as to the power half divided by 1 plus k to the So here we are completing the step growth polymerization. Now we will move to the chain growth polymerization. That is our weak link reaction. So, someone is mic on, please switch it off. So for free radical polymerization, before going to the formula, I want to share with you some basic concepts. For free radical polymerization, there are three steps called initiation, propagation, and termination that are discussed with your lectures, Professor Dhara's lecture. So here I want to show you some basic equations. That is, initiation give you 2r dot. So the rate of initiation, that is Ri, or the rate constant of this dissociation is Kd, is equals to 2f Kd and concentration of I. Why is 2? Conventionally, by UPAC convention, here it is given that 2, but 2 is taken as because one initiator give 2 radicals. So here we are considering 2, and F is the efficiency of the initiator. No initiator is 100% efficient. It will be 50%, 60%, maximum 80% to 90%. Then we will put it here 0.6, 0.7, 0.8 like this. So this is the rate of reaction. So in the initiation reaction, if we say the consumption of initiator is a first order kinetic reaction, always consumption of the initiator in the initiation step, it is a first order reaction kinetics. I0 e to the power minus kd t, and from this we can say that Ri becomes, just put I0 e to the power minus kd t to the Ri equation, it will give you this. And next we will go for propagation. Next we are one more thing, and if someone asks you to the half life of the initiator, actually initiator property sometimes defined as the half life of the initiator, that is T half, and for a first order kinetic reaction T half will be 0.693 by K, and here K is Kd, that is the dissociation constant of K. Okay. Then comes the
Ma'am, can you please show that slide number 69?
slide number 69.
Yes, ma'am. Yeah. Now, slide number 70, please. Yes, ma'am. Thank you, ma'am.
So here T half is 0.693 by Kd. Now in lecture, propagation is detailed, and propagation discussed in detail. So I am going to the propagation equation, that is Rp is equals to Kp m dot into m. And for termination reaction, RT is equals to 2 kT dot square. So for termination, in the lecture thoroughly discussed how disproportionation and combination takes place for the termination of the reaction. For disproportionation, the initiator per chain is 1 and for combination initiator per chain is 2. This is the catch. So this is a termination reaction, and for as in the propagation step, this is the actually the step this is the rate of polymerization reaction. Okay, but for the propagation step we have the initial monomer concentration is okay, Kp can be calculated, but m dot is the concentration of the radical in the system. This calculation of this practically is not possible. So we have to substitute this m dot term by some other term. So for this we are considering quasi steady state equation or steady state approximation. By steady state approximation, that is at steady state, the rate of formation of the radical will be equal to the rate of termination, that is Ri, equals to RT, that is 2 kT m dot square. Okay, so we can say that Ri is equals to 2 kT m dot square. So here from here we can calculate that m dot is equals to Ri by 2 kT whole to the power half. So you can easily put this m dot into this equation to get Rp is equals to this, So this is the basic, this is the very basic equations of free radical polymerization. Let me check if I have some problems regarding this, so that you can solve it. Okay, let's come to the problem 23. Okay. Okay. See, a bulk free radical polymerization is carried out. Now I am showing the problem which can be solved by these equations. Okay. So in problem 23, a bulk free radical polymerization is carried out 60 degrees centigrade in using benzyl peroxide as a thermal initiator. The rate constant are this, and the initiator efficiency is this, and the initial initiator concentration is this, and the initial monomer concentration is this. So calculate Ri at t equals to 0. Determine the steady state concentration at of m dot, that is formula is given here, and the initial polymerization, that is Rp, a formula is given here. I am giving you 2 more minutes to calculate it, because all the formulas are given. You have to just put the numbers and have to calculate. So I am waiting for 2 minutes. You solve this problem. 2.18 into 10 to the power minus 8. Very good. This is the correct answer. Now I am going to solve it. This is 23. So Ri is given by 2F Kd I0, that is the initial rate of the reaction. So Ri will be 2 into 0.6 into 1.2 to 10 to the power minus 5 into 2 into 10 to the power minus 3. That is giving Ri is equals to 2.88 into 10 to the power minus 8. Okay, now what is the, now determine the steady state radical concentration m dot. Steady state radical concentration m dot will be Ri by 2 kT to the power half will become 2.88 into 10 to the power minus 8 divided by 2 into 4 into 10 to the power 7. And this will give you 3.6 minus 16. This is more little plus segment plus, and this is 1.8 liter. Now we have calculated the rate of initial rate of the polymerization reaction, that is Rp. Propagation rate and polymerization rate for free radical polymerization reaction is the same. Okay. So if we have to find out Rp, Rp is equals to Kp m0 m dot. So Rp is equals to 2.85 to 10 to the minus 5 mole liter per second inverse. Okay. Now you will move with the problem 24. You try the problem 24. I am giving you 3 minutes of time, and I then you can type or
Can you show the previous slide?
okay, this one.
Yes, ma'am.
Class
Thank you, ma'am.
now Please confirm, am I audible or not?
Ma'am, just now you are audible, ma'am.
Yeah, there is a some percentage. Okay.
Okay.
So now this is the 24 number 24 problem. Ri will be 1.32 into 10 to the power minus 8, whereas m dot concentration of m dot is equals to 1.05 into 10 to the power minus 8 mole per liter, whereas Rp equals to 1.42 into 10 to the power minus 5 mole per liter per second. Okay, now I am going to solve this problem. This is problem number 24. Okay, so very initial rate of reaction is equals to 2F kdi, which gives you 2 into 0.55 into 8 into 10 to the power minus 6. So Ri will be 1.32 to the power minus 8. This is Ri, concentration of m dot, that is equals to root over of Ri by 2 kT is equals to 1.05 into 10 to the power minus 8 mole per liter, and 8 mole per liter per second. Everybody, Vidya V has raised her hand. Do you have any question? You can ask me. If you have any question, you can ask me. Okay, so it is the number 24 problem.
Ma'am, no question, ma'am.
So
Okay.
next, so this is the general problems of free radical polymerization. Now it is a specific free radical polymerization which is done by thermal initiator. Okay, do we have 1 minute? Huh? Okay, now you should solve these problems also. Okay, for problem 25, the benzoyl peroxide initiated polymerization of a monomer follows a simple kinetic scheme with all rate constant and F being independent of the conversion. For a polymerization system with M0 equals to 2m and I0 is this, limiting the conversion means the P, okay, this is P infinity problem. Okay, wait, just wait. Sorry, this is not PDKP. Okay, so this one, a thermally initiated, problem number 29, a thermally initiated radical polymerization. Uh, okay, this is also thermal initiation. Okay, let me discuss the thermal initiation. This is the equation for thermal initiation reaction, where I have discussed with you that the
Still, ma'am.
yes.
Ma'am, what about 25th for some, ma'am? 20th sum.
What about
25th sum, ma'am. You just shown that slide. 25th sum, ma'am. 25.
25? No, I'm not discussing the 25 number of sum, 25th sum. I'm just discussing this formula. After that, I will come back to the 25 number sum.
Oh, okay, okay. Thank you.
Ma'am, one second. Please show that 23-24 question slide, ma'am. Yes, ma'am. Thanks, ma'am.
Polymerization with thermal initiation. I have discussed with you the initiator concentration will decay in order of first order kinetics, and this is the rate of decomposition reaction, and here it is the rate of propagation that I have discussed with you, how this rate of propagation is coming, and initiation is the rate determining step for the for thermal initiation type of polymerization. And now I am going to show you how this rate equation can be correlate with the extent of reaction, how this can be happen, how this formula, from where we can evaluate this formula. So I am showing you the entire process, how the in thermal initiation, when the extent of reaction is P infinity, then what will be the scenario with the monomer concentration, radical concentration, initiator concentration, like that. So I am sharing with you this is okay. We have derived up to this Rp is equals to Kp monomer concentration, then F Kd I0 divided by Kt whole to the power half e to the power minus Kd t by 2. So we have derived this equation. Now Rp means rate of reaction, means rate of consumption of the monomer molecule with respect to time. As the monomer molecule consumption is negative, that is with time the monomer is consumed, so here we use the minus sign, and then this instead of Rp we substituted this by this, and here is the term is same. So now here we can just, okay, now let me write Kp m with Kd I0 by Kt to the power 1 by 2 e to the power minus Kd t by 2. Now if I am doing a rearrangement, that is minus Tm by m, this m is here and dt will go to the this side. Now if we integrate this term, then we can actually calculate the concentration of monomer at time t. So just by integrating, it will becomes minus ln m by m0 is equals to, this becomes, I'm not showing the derivation, I'm just writing it down. Now here we have derived minus ln m by m0, that is m is the concentration of the monomer at time t and m0 is the initial concentration. So if for the extent of reaction, we know that T is equals to m0 minus m by m0. So here we can write 1 minus m by m0. So m by m0 is equals to 1 minus p. So minus log ln of m by m0 will be equals to minus ln of 1 minus p. Now if the reaction undergoes infinite amount of times, then m will becomes, if the reaction undergoes infinite amount of time, then okay, for infinite time reaction, so m will be m infinity and p will be p infinity. So by substituting this into the formula that I have given to you, we can come to the expression k dt. I am not showing you the entire derivation, I am just writing the formulas. 2 is equals to minus ln 1 minus this is your last formula. This is your last last formula that you have reached with the derivation of this main formula. So here I have written the formula, that is this minus ln m by m0 minus ln 1 by p. Here it is written, but the kd but the infinite time formula is not written. You just note it down. You just note it down how this comes. The kd formula. Oh my god, where is the kd formula? Shit. Yes. This is the formula. You just note it down. This is an important formula. Okay, this is a very important formula. Please note it down. Okay, now we are going back to our problems. That is this problem is the benzoic peroxide initiated polymerization of a monomer follows a simple kinetic scheme with all rate constant and F being independent of conversion. For a polymerization M0 is equals to 2m and I0 equals to 10 to the power minus 2 molar. Limiting the conversion P infinity is 10%. To increase the conversion 20%. What would you increase and decrease M0 and by what factor? And would you increase by decrease I0 by what factor? See, we have to increase the conversion P infinity 10% to 20%. So in our last last expression, that is minus ln m infinity by m0 is equal to 2 kp f kp by kd kp into kd whole to the power half. So in this equation we can see that the rate equation does not consist of the monomer term. See, the right hand side has no monomer term. So by altering the monomer concentration, we actually cannot alter the extent of reaction. So it is the concentration of the initiator, but by what factor we have to calculate it. So our formula is
Ma'am, your voice is not audible.
yeah, I know, and I just
Yeah, okay, right now.
so the formula now my voice is audible, right?
Yes, ma'am. Right now audible.
Okay. So 1 minus P infinity is equals to 2 kpf kt kd to the power half I0 to the power half. So at first, our at case 1, our P infinity is about 10%. Limiting conversation is 10%. So here we will write 0.1. 0.1 is this, and for this I0 will be 0.1. And for the next for the 20% limiting conversion, we can write this infinity 0.2 is equals to 2 kp f kt by kt into kd half I0 to the power half 0.1. So we have to solve this equation. If I say this is equation number 1 and this is equation number 2, then just simply 2 by 1.
Ma'am, in I not first equation,
It
0.1 is coming.
is 0.2.
Yeah, right. Yeah.
Okay, minus ln 1 minus p infinity point 2 divided by minus ln. Now this two term will be cancelled out. This two term will be cancelled out, and it will becomes I0 0.2 divided by I 0.1 to the power half. So it will become ln 1 minus 0.2 divided by ln 1 minus 0.1 will become I 0.2 by I 0.1 whole to the power half. Someone might be breaking. Two point two, then I 0.2 by I 0.1 become 2.2 square, and it is become 4.84. So the initiator concentration will be increased by 4.84 times to get that last reaction of 20%. Okay, this is how you can approach the problem like this. So we have last 5 minutes. You can try problem 29. No, sorry, you can try problem 26, and I will share the answer.
Ma'am, ma'am, shall you please show the previous slide? Yes, ma'am. Thank you, ma'am.
And the last problem is problem number 30.
Ma'am, in previous slide,
Hmm.
can you tell me the 2.2 whole power square is there, right?
Yes,
So that
4.2.
is mathematically it will come, right?
It is a math. It's math, simple math.
I 0.2 divided by I 0.1 whole power 1 by 2 is that.
Yes, I 0.2 by I 0.1 to the power half is equal to 2.2.
Yeah. So yeah, and the minus 0.2, that is become 2.2, right?
Yes, yes, yes.
Okay. Then how it will become 2.2 power 2 1? That is mathematically represent, right?
That is okay.
Uh,
I'm showing you. I'm showing you. It's last. It becomes minus 0.22 divided by minus 0.10 is equals to I 0.2 by I 0.1 whole to the power half. It becomes 2.2 then when half comes to the other side of the is equal to sign, then it will be the just reverse of half, that is 2. This is a mathematical tool. Now it's clear.
yes, ma'am. Right now I'm clear.
Okay,
Thank you.
so try problem number 26.
Ma'am, ma'am, can you please explain 22nd problem, ma'am? 2, ma'am. 2, ma'am. Ma'am, in explanation.
Diol and diamine shown here. The excipient concentration of H2O is equal to 150 and the initial monomer concentration, that is the reactant concentration, is 1.5. This is your M0, this is M0, and this is your K. Characteristics in a closed structure. That the potential Xn will be. So for closed system, our equation is this: Xn equals to 1 plus K to the power half. So we just put the values. 1 Xn equals to 1 plus 150 to the power half, and by that we get 11. I think by that we get 11, no, something 13.24. We get polymerization 13.24. Xn is clear.
Yes, ma'am.
In the formula for a closed system, the extent of reaction P, the maximum extent of reaction that is in equilibrium, is shown by this formula. So we are just putting the formula, putting the value of K, and we will get the extent of reaction. And the H2O, that must be lowered to obtain the degree of polymerization 150. It means at degree of polymerization 150, what will be the amount of H2O will be produced? The amount of H2O will be produced, that should be lowered to carry out the reaction forward in forward direction. So it's actually asking you the what will be the concentration of H2O when the degree of polymerization is 150. So for this we have a formula. The concentration of H2O is this. So we will put the formula and get the answer. Is it clear?
Yes, ma'am. Thank you, ma'am.
problem so that you can. Okay, 26. 26 answer is 4.8. I0 what 0.15. Oh, sorry, 1 minute. I0 0.3 divided by I0 0.15 equals to 4.8. Is it clear? This is the answer of the problem. You just try it out. From the next coming class, we will start from this. Okay. So that's all for today. Anybody have any query?
Ma'am, I have some questions from week 2 assignments is there. Question number 5, 6, and 9. Can you explain that if possible? Ma'am, week 2nd, week 2. It's over. Week 2. Week 2. It's over. It's over.
The problem, big assignment. This one,
Yeah.
which one?
Question number 5, ma'am.
Question number 5. Yes, this one. The feed ratio of acetic acid and ethylene glycol that should be employed to obtain a.
Yeah, I want to know down the full answer, ma'am. Yes, ma'am. Answer, I want full answer. Like how you got 0.99 that. Like in question number 4, I got 9.02. But here answer is 98.8. Can you explain that how that answer come?
Okay. So
Question number 4.
question number 4. The weight average molecular weight of an equimolar mixture of adipic acid and hexamethyldiamine found is 22600. Find out the conversion. Okay, weight average molecular weight. Formula for weight average molecular weight. Going back. Okay. The formula for weight average molecular weight is. Let me note it down first. Let me calculate first.
Actually, for this fourth one, we have to apply two formula. Sakshi ma'am.
Hello, yes, ma'am. Yeah.
So for this, we have to apply two formula. Actually, xn equal to m1 by m naught first.
Okay.
And then we have to use one more formula also, xw equal to mw by m naught. Actually, here the
Okay.
mw value is the given value, weight average, right?
Yeah.
22,000. And
Ma'am,
then,
I followed the two formulas, but my answer is 98.02. Here the answer is 98.8.
no, actually, the exact answer it is coming here is 99.
Okay.
So for that m naught value, you substituted as 113. Is it correct? M naught value you have to substitute as 113, ma'am.
Okay.
Then 22,600 divided by 113 it equals
Yeah.
to 200. So based on that, we have to go to the calculation.
Yes, ma'am. This is clear, ma'am. Can you explain the fifth question, ma'am?
See, the analogous problem is the question number 14. I am showing to you. Okay. Um, so here in and P is 99%. So we have to calculate R. For that we have to first calculate average molecular weight. Average molecular weight, that is one. That is it is number 4. Adipic acid and hexamethylene diamine. Okay. Adipic acid and hexamethylene diamine 116 plus 146 by 2, and that will give you.
Ma'am, your voice is not audible, ma'am.
Question number 6. There I got 0.05. In that, we have to put that value, the one value which come in question number 5.
Yeah, what fraction of the reaction mixture still exists as a dimer? Yes. Uh,
Can you tell me please question number 9 then? 9.
the amount of benzoic acid should be added with a mixture of 2
Ah.
mole acetic acid, 1 mole hexamethylene diamine to produce in 12,099.5% concentration. Yes, benzoic acid is your chain stopper for the termination. So here is the formula. Like, that's the formula. Just a minute. Just a minute. See, I cannot find it out. Can you send me your mail ID so that I can send you the solved version of this?
Okay, ma'am. I will type here.
Yeah, yeah. You will type here. And I will also upload the slides of the week 1 and week 2 problem in detail solving so that you can get it from there also. Okay.
Yes, ma'am. Ma'am, I sent that mail ID. No, please send me the answers. No.
Okay, okay, okay. I will send you, and also I am uploading the slides. I am uploading the slides for the solve of the week 1 and week 2 problem. You can find it there also.
Yes, yes, ma'am. Yes, ma'am. Thank you.
Ma'am, ma'am, one doubt, ma'am. Ma'am, in week one assignment, ma'am. So in that, I got eighth and ninth answer correct, ma'am. That number average and weight average. So, but the polydispersity index, I got the value of 1.30, ma'am. Week one, last question, ma'am. Yes, ma'am. I got 1.30, ma'am. But number average, I got 15,545. That falls in this range only, ma'am.
Okay, one second.
Yes, ma'am. Last one, ma'am. Polydispersity index.
Did you submit the test?
Yeah, ma'am. I also got the same answer. That I don't know why it is like.
1.30, ma'am.
Okay, so I will check the answer, and I will upload it in my site. I will put the link so that
Yes, ma'am. Yes, ma'am.
Uh,
Because,
Hello,
ma'am,
ma'am.
our
Hello, ma'am.
answer is because
Yeah, yeah, that benzoic acid problem, that question number 9 is also like I also got a wrong answer. So just can you just upload that answer in the site? Question number 9, that benzoic acid, Vada.
I will upload the all solve of the week problem so that you can access it to my to this to mail ID so that you can access it. Okay.
Okay, okay.
Okay. Thank you. Any other queries?
Ma'am, good evening, ma'am. Ma'am, today all the problems only send me, ma'am. I send my mail ID, ma'am. Tamishli, ma'am.
Today's problem.
Today's problems only, ma'am. Slides, ma'am.
Today's problem.
Yes, ma'am.
Okay.
Yes, ma'am. Okay, ma'am. Thank you, ma'am.
Anyone else? So I call off the meeting. Thank you.
Yeah, thank you, ma'am.
thank you, ma'am.
হ্যাঁ বেরিয়ে যাও তুমি তুমি বেরিয়ে যাও ফুড স্টুডিও আমি ল্যাবে হ্যাঁ কেন হ্যাঁ ঠিক আছে তুমি ক্লক টাওয়ারে দাঁড়াও তুমি তাহলে কি করবে ক্লক টাওয়ারে মানে তুমি এক কাজ করো মেন গেটটাতে চলে আসো গোল চক্করে তারপরেরটা ডিপার্টমেন্টে না গোল চক্করে না না মেন গেট মানেই গোল চক্কর তুমি দেখো ওই যে ক্লক টাওয়ারের পরে সোজা আসলে যে একটা একটা আইল্যান্ড করছে সেটা তুমি আমি জানি আমি জানি তুমি তাহলে ক্লক টাওয়ারেই দাঁড়াও আমি আসছি ঠিক আছে মানে